Hi, this is Mr. Dudley. As I promised, here's a video on subtracting mixed numbers using the four S's. We're going to subtract 9 and 1/4 minus 3 and 1/3. So let's get started. The first thing I need to do is draw quadrants, and that is just so we can stay organized while we're solving our problem. Okay. All right, in the first quadrant, we're going to rewrite the problem because you're not always going to have a lot of space to solve, and you might want to recreate this on your scratch paper. So the first step here is to rewrite the problem. 9 and 1/4 minus 3 and 1/3. That is the problem we're solving. Okay. The first S, again, is skip counting. We're going to skip count. There's the S. We're going to skip count these two fractions to find common denominators. So the first fraction is 1/4, and the second fraction is 1/3. Okay, and I'm going to skip count these fractions to find equivalent fractions that we can use with common denominators. So skip count by ones is easy. 1, 2, 3, 4. And then we're going to skip count by fours. 4, 8, 12, 16. All four of those fractions are equivalent. All three of these would simplify to 1/4. All right, let's do 1/3. 1, 2, 3, 4. And then we're going to skip count by threes. 3, 6, 9, 12. Okay, I can see already what my common denominator is going to be. Do you see it? 3/12 and 4/12 both have 12 as the denominator. So I'm going to keep track of which one goes with which. Okay, 3/12 is equivalent to 1/4. So I'm going to, down here in this quadrant, I'm going to do the next S. The next S is to substitute. I'm going to substitute, and then I'm going to solve. Now, when we're subtracting, we're going to add a step in between. Okay, we're going to borrow right here. Oops. We're going to borrow before we solve. That's it. That's the only difference between the adding and subtracting steps. Okay, so let's substitute those equivalent fractions. We're going to rewrite it with 9 and 3/12 minus 3, and now instead of 1/3, I'm going to write 4/12. Okay, and you're going to notice something. We've substituted, so we did this S. We can't solve yet because when we subtract these numerators, 4 is bigger than 3, and that would give us a negative number, and that is not going to be helpful. So we've got to do something in between called borrowing, and it's a lot like borrowing when you subtract 2 or 3-digit numbers. We're going to borrow from this 9 and make this fractional part of this mixed number bigger. So I have to take this 9, and I'm going to borrow from the 9 and make it an 8. And then I'm going to add one whole to the 3/12. And you do that by adding 12/12. Okay? So I'm going to rewrite it here. I've got 8 plus 12/12 plus 3/12. What I did was I took 1 from the 9 and I turned it into 12/12, which equals one whole. So 8 and 12/12 still equals 9. Let me make that really clear. Everything inside of this green box still equals 9. Okay? But now we've got a fractional part here that we can add to this fractional part, and we'll have a bigger numerator on this first mixed number so that we have enough numerator to subtract from. Okay, so let's simplify that a little bit. 8 is going to stay the same, but we're going to add these two denominators. We're going to add 12 and 3, which is 15, and the denominator stays the same. Okay, so 8 and 15/12 is equivalent to 9 and 3/12. We just rearranged one whole. Moved it from the whole number to the fraction. Okay, and then the second part we don't need to do anything to. We'll just rewrite it. 3 and 4/12. Now, all we have to do is subtract the numerators. So I'm going to subtract 15 and 4, and that's going to be 11. Okay? I'm going to do the whole numbers. 8 minus 3 is 5. And my denominator will stay the same. The denominator is 12. It stays 12 because it's a common denominator. Common means same. So my answer is 5 and 11/12. The last step is to simplify. That's the fourth S. Now, let's check and see if we can simplify 5 and 11/12. Can we simplify it? The way we check is we take our prime numbers, 2, 3, 5, 7, and 11, and we see which of those prime numbers will go into both the numerator and denominator. I can tell right away that 2 will not go into 11 and 12. It'll go into 12, but it won't go into 11 because 11 is an odd number. So let's check 3. Will 3 go into 11 and 12 evenly? Well, 3 will go into 12, but it won't go into 11. 5 won't go into either because the only numbers that 5 will go into evenly end in a 0 or a 5. 7 won't go into both evenly because the first multiple of 7 that is 14, and that's more than both of these. So 11 will go into 11, but it won't go into 12. So I believe that we have simplest form here. So we used the 4 S's to solve this subtracting mixed numbers problem. We first skip counted to find the common denominators. We substituted the common denominators for the fractional parts so that we have common denominators down here, and we rewrote the problem. We borrowed in between, which is the difference between adding and subtracting as far as the steps go. We solved, which is the third S. And then we didn't need to simplify because this is the simplest answer. So that's how you use the 4 S's to solve a subtracting mixed numbers problem.